All right, welcome to week one, part two, in which we're continuing to review things from the introductory course. Now, actually, near the tail end of this are a couple of things that I did not cover in my intro course. So, for those of you who took intro from me, you will see a couple of new things here. Alrighty. Well, first we have a rhetorical question. Now, I guess if I were conducting this live, I could ask you this question and ask you to answer it for me. How can some external Python library or module called mylib be pulled in or accessed within your current code? And the choices are, can you say import mylib? Can you say import mylib as Bob? Or can you say from mylib import some specific function? Think. Well, the correct answer, as you know, as you should know, is all of the above. You can import either the entire module mylib under its own name, or using an alias name, or you can import individual components from the library. What are loops used for? Can you use a loop to iterate through a list? Can you use a loop to iterate through a range, like from the range function? Can you use a loop to iterate over the lines from a file? Well, again, ding, 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 the correct answer is all of the above. Okay, now we're going to take a look at some of the built-in collection types that Python provides. We know about lists already. Well, you should know about all of these things already. A tuple is like a list, except a tuple is immutable, and when you create a tuple, you do that using parentheses rather than square brackets. So basically, a tuple is used for grouping or collecting together some collection of values that you don't intend to change. For example, if you have a student record from a database describing the student's name, the student's Andrew ID, the student's email address, phone number, and so on. Although that data is related because it's all descriptive of a particular student, you would not expect that information to change. That's sort of like read-only information. A list, on the other hand, is a collection of values in which you could either change values or add more values or whatever. Here's an example of defining a simple tuple called t, containing these int item values, 1, 2, 3, and we can access the initial item from t by saying t sub 0. If we attempt to say t sub 0 gets a 5, here we get yelled at, does not support item assignment because a tuple is immutable, unlike a list. We can test whether a particular value is in a tuple using the in keyword. So 0 in t is false, 3 in t is true. We can also use a for loop to step through all of the item values in a tuple. Here I'm just printing out each one, and print by default is going to display each of these on a separate line. I can use the len function to find out how many items are in the tuple. I can also do things like counting how many times a certain value occurs, or using index to locate the subscript for a particular item. And if the item doesn't exist, I'll get yelled at. Okay, this is a value error exception just like trying to say t sub 9, we get basically the same error, but this time it's called an index error. To create an empty tuple, you simply use empty parentheses. So x gets empty parentheses means the x is a tuple, but it contains no values at all. Now, the odd notation here is if you want to create a tuple of one item, you have to use a comma after that item value. All right, so y here is what's called a one tuple. Its type is tuple, and its length is 1. And as you ought to remember from intro, if you say something like some variable name gets just plain 4 and you don't use the comma, well, in this case, the parentheses don't indicate a tuple. They just indicate grouping, and it's as though I had just said y2 gets 4. Okay, so that use of the parenthesis is just like if I had said something like y3 gets 3 plus 7. That parenthesis does not create a tuple containing 3 plus 7. It just creates an arithmetic expression, 3 plus 7, and the result of that, which is 10, becomes the integer value of y3. All right, so we can find out that y2 is an int, and y3 in my examples here is also an int. So that's tuple. A set is an unordered collection of items with no repeated values. All right, so all of the items in a set are guaranteed to be unique. And to create a to create a set using in the same way that we would create a list with square brackets or a tuple with parentheses, we instead use the curly braces. So here I'm saying set 1 gets curly brace 0, 1. All right, so now I have a set that has 2 values in it, but a set, remember, is unordered, and therefore using subscripts on a set doesn't make any sense. The square bracket notation to do a subscript requires the items in the collection to be ordered, and a set is not ordered. However, we can obtain a particular value from a set. It's not shown here in these illustrations. For example, I can loop through the items in a set. And this will display the values without changing the values. I also can use the pop facility if I could spell, would be helpful. And the pop facility will remove and return some arbitrary value from the set. So now set 1 value, in my case, happens to be 0, and set 1 no longer contains the 0. Now, pop, although pop appears to be returning the, quote, first item, unquote, from the set, in fact, there's no guarantee about what item you're going to get. The fact that set1.pop returned the 0 here rather than the 1 is just a coincidence. Now, on your particular system, it might be a consistent coincidence. That is, you might always get this behavior, but the language does not specify that that's the behavior. The language says that pop just returns some arbitrary value. You can add an item to a set using the add function. So if I say set1 dot add 0, that will put 0 back into the set. If you add to a set a value that's already there in the set, then that's not considered an error. It just doesn't do anything. Okay? And I skipped this value, or this example here. Let me do that one. If I say set2 gets curly brace 2, 3, 2, you will notice that in the initial list of values there are 2 2s, but the second one is just kicked out, so that I only actually have the unique values 2 and 3 in my set. Again, because a set is not ordered, it is illegal to say something like set1 dot append a value. You would use set1 dot append with a list in which the items are ordered to put something at the end, but the set is not ordered, and so we use add rather than append. We can do the kinds of things that we expect to be able to do with sets. We can compute unions of two sets, intersections of two sets, differences between sets. And let me go through these examples. Here I have a set referred to by this variable name capital A, 1, 3, 2. Now, I've defined the set by giving values in the order 1, 3, 2, but the set is unordered, and so by coincidence, in this case, A displays as 1, 2, 3. If I say B gets 5, 3, 4, B displays as 3, 4, 5, but again, that's just coincidence. Now, there are named operations you can use for doing unions and intersections and differences. You can say A dot union B. That's kind of awkward, so usually people use these symbols. A vertical bar, whoops, capital A vertical bar, capital B is a union. You may or may not. This is basically borrowed from C language notation, in which Python is one of many, many, many languages that are sort of kind of almost derived from C. And the vertical bar means or. All right, so A or B means the union of A and B. The ampersand, A and B, well, I said it. The ampersand is interpreted as and so this is the intersection. It's going to give me the items that are in A and also in B, and there's only one common item, which is the 3. Now, if I say A minus B, what I'm going to get is all of the values in A that are not found in B. All right, so 1 is not found in B, 2 is not found in B, but 3 is found in B. So I will not get the 3 as the result of this difference. I just get a set containing 1, 2. If I do things the other way around, whoop, B minus A, then each of the items in A will be removed from B. So 3 exists in A and will be removed. 4 and 5 do not exist. And so the result that I have is 4 and 5. Now, I may have misspoke just a moment ago about things being removed from B. Actually, none of these expressions that I've done here change A or B. A and B are not changed unless I say A gets, something new. So I could say A gets A capital A intersected with capital B. I could say that if I want to change A to refer to the union of the original A and B, but now A is changed. And so consequently, if I say something like A minus B, I'm going to get the set of values 1, 2, 3, 4, 5 minus the items that are in B, which is, it's off the top of my screen a little bit, which is just 3, 4, 5. And so what I'll end up with is 1, 2. All right, so that's set stuff. There's a lot more to sets, but this is kind of the fundamentals. One convenient thing that you can use sets for is as a way of eliminating duplicates within a list. So let's suppose that I have my list here. I'm doing this example down here below, well, below example. So I'm going to say my list gets 1, 2, 3, 4, 3, 2, 1. So my list is a list that contains 7 items. It does have duplicates. If I want to eliminate those duplicates, a cheap and easy way of doing that is to create a set by using the set conversion function on my list. All right, so that's going to get a copy of the list, convert that copy into a set. S now just contains the unique values. And now I can create a list of those values by using the list conversion function. Okay, so now I have started out with a list called my list containing 7 values. And by creating a set from my list and then creating a list from the set, I get a list containing just one unique copy of those values. Now here I have got this intermediate variable s sitting around containing a set or referring to a set that I probably no longer need. So a more direct way of doing this without creating this intermediate variable would be to just say, let me do this with M3. I can say M3 gets a list from a set built from my list. Oops. Now I accidentally hit the line continuation character, so that's okay. I just have to hit the enter key again and again. Okay. And there we go. So now I have, now I see the value of M3. All right, so we know about lists, tuples, and sets. A dictionary is, now I didn't say this, that a set is immutable. And it's, I mean, it makes sense that that's, no, I said that incorrectly. A set is mutable because we can add things to it. All right, so a list is mutable, a tuple is immutable, a set is mutable, and a dictionary is also mutable. A dictionary is also created using curly braces like a set, but we also have to use a colon when we create a dictionary to separate each key from its corresponding value. Okay? Now, this says a set is unordered. Now, that used to be true in the current value, in the current implementation of Python. Actually, these records in the dictionary are ordered in the order of key creation. Okay, so it's often considered to be poor style or to produce poor maintainability to assume that the items in a dictionary are ordered, but in fact, in the current version of Python, they are ordered. Okay, and we access the value associated with a certain key using square brackets. All right, so let's take a look at specific examples. Here I am saying D gets, my key is 3, and the value associated with 3 is dog. My next key is 8, and my value associated with 8 is cat. And my third key is 12 with a value of gopher. Whoop, curly brace, not parenthesis. There we go. So this is a dictionary of 3 key value pairs. The keys are 3, 8, and 12. The associated values are dog, cat, and gopher. I can confirm that D is a dict. I can find out that the dict has 3 keys in it. And if I just say D, that will display the entire dictionary. I can use the key as a subscript. So I can say D sub 12, and that gives me the value gopher. D sub 3 gives me the value dog. D sub 0 is going to be an error when I try to use that key to look up a value because 0 does not exist. Okay, I get told key error 0. Now I cannot look up keys from values, so I cannot say D sub gopher to find out that the key for gopher is 12. Why is that? Well, keys are required to be unique in the same way that values in a set are required to be unique. But values are not required to be unique. So there is a direct mapping from a key to that key's value, but there is no direct mapping from a value back to its key, because we might have the same we might have the same value associated with multiple keys. So for example, I might have something like this. Stews is 1 colon John, 2 colon John, 3 colon John, 4 colon Sue. So I have, no, I guess Stus looks like a kind of odd variable name. My intention here is for this to be a dictionary of students, mapping from the student ID to the student's first name. This thing is a dictionary. This thing has 4 students in it. And if I ask for the student with ID 1, I get told, well, that student's first name is John. And if I ask for the first name of the student with ID 2, well, that also happens to be John. And so you can see that it doesn't make any sense to ask what is the key for John. Won't work. There's multiple Johns. Okay? Now, although you can't do a lookup of a key that doesn't exist using square brackets, it turns out that you can simply do an assignment to add a new value, a new key value pair into your dictionary. So I can say D sub 15 gets the string mouse, and now my dictionary has had that additional value added. I can use the in operation. I can test whether mouse is in D or whether zebra is in D. Okay, and here at the bottom of this slide in the notes, I'm testing whether 15 is a key. Oh, I'm sorry. I've been chattering away here without paying attention to my own examples. I've made the same mistake here that I made up here, all right? You can ask whether a particular key is in a dictionary. You can't ask whether a particular value is in a dictionary. So when I said mouse in D, I got false, because mouse is a value, not a key. But if I ask whether 15 is in D, that is true. And if I ask whether 20 is in D, that is false. I can use this Boolean value in an if test, so I can say something like, if 15 is in D, print the value associated with that key 15, which is going to be mouse. Or on the other hand, if I say if 23 is in D, then show me the value associated with the key 23. Well, there is no key 23, so this if test fails, and consequently the print is not executed. All right, so next up we're going to take a look at functions. And a function is sort of like a variable, except a function refers to a unit of executable code rather than to a specific value or collection of values, such as an int or a float or a list or a set or a dict. All right? In order to use a function, you have to call the function by putting parentheses after the name of the function. A function often takes one or more parameters that you pass in to modify how the function behaves. And very often, if the function computes some kind of value, it will need to pass that value back to the code that called the function using a return statement. Okay? So here are the required parts of any function definition. You have to start out by saying def, that's a keyword. You have to specify a name, and the name can be anything that would also be valid as a variable name. That is, the first character has to be an underscore or a letter. Subsequent characters have to be underscores and or letters and or digits. You're required to have parentheses to contain the parameter list, although you're not actually required to put any parameter names in between the parentheses. And you also are required to have a colon at the end of this def line, and it's very easy to forget that. Following the colon, you then have to have at least one statement, and that statement has to be indented relative to the def keyword. And then any additional statements that you have also have to be indented at exactly the same level. If you wish to pass a value back to wherever the function was called, then you can put in a return statement. So here I have, I'm not sure that this copy and paste is going to succeed. Let me give it a try. I think my new lines are going to be messed up. Yes, my new lines are messed up. So that didn't fly. Let me just type this thing in by hand. If I say define compute total, all right, so compute total is my function. That has to be followed by a parenthesis. And now if I wish, I can give parameter names. I'm going to give count and price as parameter names. And then indented, I can have my sequence of statements. Subtotal gets count times price. Now we're assuming that this is in a store somewhere. So unfortunately for us in Pennsylvania, and specifically in Allegheny County, there's going to be sales tax, and that tax, unlike what's shown in this slide, lucky for us, is going to be 7% in Allegheny County. Well, I'm not going to try to spell Allegheny. I always spell that wrong. Well, okay, so now we have computed the total amount that a customer is going to have to pay based on the number of items and the price of each item with the sales tax added in. So we're going to return the subtotal plus the tax as our result. All right, so that defines the function, and now in order to call the function, I can pass in some values. Okay. So I'm going to say compute compute total of 5 items that cost $1.99. So that should be less than $10, right? Each item is less than $2. We got 5 items, should be less than $10. Ouch! I forgot the sales tax. So I'm going to end up having to pay an additional 7% in sales tax. And of course that's actually in real life that's going to be rounded up to 65 cents. Okay. Whoop. When you call a function, basically what happens is that the Python interpreter jumps from where it currently is executing to the block of code associated with that function, and that code is executed, and we then come back to the following statements below the function call. All right, so here I just did a similar example. Compute total with a quantity and a price. Here we are saving the value into a variable so that we can refer to it later. So let me create total amount is compute total, and I'll use the values here in the example. 10 items at $5 a piece. $50, right? No, sorry. $53.50. Okay. Okay, I don't think there's anything wildly new happening here. So let me just talk through these without actually doing them. It is possible when a function returns a value to take that value and immediately turn around and pass that value as an argument to some other function. So here we're calling the input function. That function is going to display a prompt and then return a string that the user types. We're immediately passing that to the int conversion function. All right, so items here is going to be an int value, assuming that the user did type an integer. Similarly, we're going to ask the user for the cost of each item and convert that to a float. And that will work if the user typed the correctly formatted thing. And then we're computing the total by calling our compute total function. Now, you'll notice that we got, in my examples, we got values like 10.6465 and 53.5. Neither of those is what a customer would want to see on a receipt. The customer is going to be used to seeing dollars, dot, and then dimes and pennies. So we can say, we can use the %5.2f format to make that stuff look more reasonable. Total is dollars, and then %5.2f with my value of, let's say, tot amount. All right, so now I've got $53.50, or I can say, let me copy and paste this part. And then I'll copy and paste my compute total function up here. And now we have $10.65. Okay, so nested function calls is perfectly fine. It is possible in a return statement to return multiple values rather than just one. And if you do that, what you get back is a tuple. Now, you can receive that tuple into a single variable. Here I'm defining fn to be a function that takes no arguments or no parameters, and that returns a tuple consisting of 10, 3.1, and dog. If I say r gets fn, r is now a tuple, but I can also do what's called multiple assignment. If I know that there are 3 values in the tuple coming back from fn, I can say a, b, c, separated by commas, gets fn, gets fn's return value, and that way I can separate the values in the tuple to be referred to by separate arguments. All right, so by default, if you say return and you give a sequence of values separated with commas, what you get back is a tuple. If you would rather get a list or a set, then you can use square brackets around the values if you want to get a list, or you can use curly braces around the values if you want to return a tuple, a set, okay? It's also possible when you define a function for the function to have so-called default arguments. Here, in this example, I'm saying define fn2 to have 2 positional parameters and 1 so-called keyword parameter, which has a default value of 3, a default argument value of 3. All we're going to have our function do here is to print out the values of these 3 parameter variables, a, b, and c. All right, so positional parameters always have to be given first in a function definition, and then keyword parameters, if any, have to come afterward. The way this function works now is I can say fn2 with, let's say, 3, 6, hello. Notice that the fact that the default value for c here is an int doesn't matter at all in Python. I can go ahead and pass in a stir or a float or a bool, and it will work just fine. And what is going to come out here is, well, the value of the parameter a, or the value that a refers to, is 3, the first argument. The value that b refers to is 6, and the value that c refers to is hello. But if I don't specify any value for that third argument, let me say 2, 4, 2 and 4. Very clever. If I don't specify anything for the third parameter, I get a 3 by default. Okay, so the value of c by default, if I don't specify a value, is 3. That's how keyword parameters behave. Now, because these first 2 parameters are positional parameters, that means that I must give at least 2 arguments. If I say fn2 9, I'm going to get yelled at because I have to specify at least 2 argument values for the fn2 function. You can use the star notation conventionally with args, or var args, actually is more common in Python, to indicate that you want to retrieve some arbitrary collection of values and store those in a tuple whose name is going to be args. Okay, so let me do that one. So we've got, I'm defining a function fn3, which is going to take a variable number of args. And because that's, I forgot to say this, but that's going to be represented, I guess it doesn't say it on the slide, that variable number of args is going to come in as a tuple. So let me, in addition to what is happening in the example code, let me say args is, or let me say, type of args, and the type description is going to be type args. It's going to be a tuple. And so because it's a tuple, it's a collection, I can iterate through it by saying for arg in args, print arg and the type of the particular arg. All right, so now if I say fn3 with no arguments at all, that turns out to be legal. And what I have is an empty tuple. Okay, so the type of args is tuple, but there are no individual argument values, so I don't get any result by executing this for loop. If I say fn3, 1, now I have a tuple containing 1 value. If I say fn3, hello, comma, world, comma, exclamation mark, I now have a tuple of 3 strings, and I get each one of those strings out on a separate line. fn3 of high 15, 23.4. Doesn't matter, 23.45, and true. Okay, now I've got a tuple of 4 values. A stir, an int, a float, and a bool. All right? Now, it is possible to pass a collection into this fn3. Here I'm passing a list into this function fn3, and consequently within fn3 what I'm going to have is a tuple containing 1 list. And that's perfectly fine. Okay, so args is still a tuple. The only value in that tuple is the list containing the integer values 1, 2, and 3. If you want to take a collection, well, I didn't quite highlight what I wanted here, so let me do it on my screen here. If I say fn3 and then I say star 1, 2, 3, the star operator, it's not being used as multiplication here. The star operator in front of a collection is saying to Python to expand that collection out to its individual components. And the result that I get is going to be the same as if I had said fn3, 1, 2, 3. Okay, so that's something that I think I did not mention in my intro course, but it works for any kind of collection. If I say fn3 star and then I have a tuple, okay, that's the same as saying fn3 and then giving the individual argument values, hello, 14, and false. All right. Okay. Here we have in fn4 a function that takes 2 positional arguments followed by this variable list of arguments. And finally here we sort of have the culmination of all this thing. We have 1 positional argument, 1 keyword argument, and variable arguments with star args. So let me skip over fn4 and we'll do this last one, fn5. So this has a positional argument that we're going to call a, or the parameter is a. We also have a keyword argument, which is going to have the default value 3. Now, notice in the example that there are no spaces around that equal sign. That's fine. That's actually probably the most common notation. I'm just in the habit of putting spaces around my equal signs, and that's perfectly fine too. And then we're going to have star args out here at the end. We're going to print the value of A and B, the values of those two items A and B. And then we're going to print the value, we're going to use a for loop to step through each argument in the args tuple and print out the individual arg value as well as the type of that argument value. So now if I say fn5 and I just give a 6 as an argument, I just give one argument. Well, 6 is going to become the value of A. The value of B by default is going to be 3. And args is going to be an empty tuple. So all I'm going to get out is the value of A, which is 6, and the value of B, which is 3 by default. And then the args list is empty, so I get no output from that. If I say fn5 of high and 23, well, then A is high and B is 23 rather than 3. And finally, if I say something like fn5 sub 123, howdy, true, false. Oh, and let's create a set containing 1, 2, 3. This is fine. The value of A is going to be 123. The value of B is going to be the string howdy rather than the int A. And then args is going to be a tuple containing true followed by false followed by the set 1, 2, 3. And there we go. Okay, so I hope that that is a reasonable reminder of what's going on with defining functions with positional parameters, keyword parameters, and then variable arguments. Variable arguments may be new. I think it's new to those of you who had the intro course from me. I'm not sure that we did that. I don't remember. All right. Now, here I've got a function in which I've just used ordinary parameter names. So technically, these are not keyword parameters. This function is called fn6. And I have name and cost. And within here, I'm going to say print. The name is, and then I'll have a 10-character wide field containing a string. And the cost of one item is $5.2f. So that's going to be a floating point number. And name and cost are going to be provided as the two values to be formatted. So there's my fn6. If I say fn6 of hammer and 22.74, I don't think I'd want to pay $2,200 for a hammer. Okay, so here I get told that this is a hammer and it costs $22.74. Now, it turns out that even though these two parameters, name and cost, are not technically keyword parameters, Python will allow me to use them as though they were keyword parameters. And I can say fn6 sub name is pen, cost is $1.97, and this works. Oops, it would work. I typed one too many parentheses. Let's try that again. And this works. Okay, there we go. If I specify the names of the parameters, I can actually reverse the order of these things. Oh, what costs $2.25? A more expensive pen. All right. So now I've got a $2.25 pen. I guess actually by today's standards, those are very cheap pens. So I guess I'm showing my age here. So you see that you can optionally use the parameter names as to define keyword names. Frankly, this isn't done very much. It's kind of awkward to do, but you can do it. All right, next up, we're going to illustrate something called lambda expressions. A lambda expression is a function that does not have a name. And you can pass the lambda expression. Well, first of all, you can call a lambda expression by putting a list of arguments in parentheses after the lambda expression. So here is a lambda expression. We say lambda of some variable I squared. Cool, I have defined a lambda expression. Python knows about this nameless lambda expression, but I haven't used it for anything, so it just sort of disappears into thin air. It's a little bit like saying 5. Okay, 5. It's, I've defined an integer, but it just sort of disappears into thin air. So in order to use the lambda, I can put some squareable value as an argument in parentheses after the lambda. And notice that I have to enclose the lambda in parentheses to do this. All right, so there's the value of 123 squared. It is possible to provide a variable name to contain the lambda. So now, instead of the lambda sort of vanishing into thin air, I actually have a variable name sitting around referring to that lambda. And so now I can say SQR of 12.34 to get the square of 12.34. Some people... Okay, I never like to get into style fights. When I was young, back in the last century, I used to get into arguments with people about proper style and so on. And I guess it's useful to do that because it does cause you to examine your theories about style. The most important thing about style, well, two things. First of all, you should have a consistent style. You should not write garbage-looking, randomly formatted code. You should follow a consistent kind of style. The second important thing about style is that if you get hired by a company, you should use the style that they use. And just hold your peace if you really hate the style that they use. Tough. They're paying you. Use the style that they use. End of discussion. Okay. In any case, so some people consider this idea of naming your lambda to be bad style. A function that enables you to apply a lambda to some arbitrary collection is this function called map. And this you may have encountered in things like R or, R, the R statistical language and environment. And what it does is it produces an iterable of all the values of some collection to which some lambda has been applied. All right, so here I'm creating, using a comprehension, this list A, I for I in range 10. But I only want even-numbered values, so I'm going to say if I mod 2 is 0. All right, so A now contains 0, 2, 4, 6, 8, and if I apply the map function in this for loop, okay, map is going to produce an iterable that I can loop through with this for loop, and the first, notice that well, that may be slightly below what you can see, but I do have a little syntax help here telling me that the first argument has to be a function and the second argument should be a collection through which I can iterate. So I'm going to have lambda I colon I squared as my first argument, and then A, my collection, as my second argument. And what I'm going to do here is I'm going to say print J. So I'm going to get from this the squares of 0, 2, 4, 6, and 8. All right? Now, with the map function, you can actually apply a named function as well. So if I say something like from math import exp, that's the e to the x function, I can say for j in map exp a, oops, sorry, I forgot my colon, and I can say print j. So now instead of j being 0, 2, 4, 6, 8 squared, I'm going to get e to the 0, e to the 2, e to the 4, and so on. All right, so that's the map function, as well as lambdas. You typically want to store function definitions into a script file or into a program file so that you can then make use of those functions later. And you can create scripts or programs, as we know, using any integrated development or text editor that you like, idle, spider, PyCharm. If you're a Linux person, you can use VI or Emacs or what have you. And we've already talked about this idea of how you can import either entire modules or just components from modules. So I can import some module by saying import on the name of the module. Then I have to use the module name as a prefix when I want to access a name from that module. If the name of the module is long, I can specify an abbreviation using as. And if I only want individual things, and I want those to be available at the top level, I can just say something like from the module import fn, and then I can say fn parentheses without having to prefix with the name of the module. Okay. It's also possible and desirable when you're writing a well-designed Python module to have something called the main function for the module, which typically contains test code. You separate the invocation of main from everything else with this so-called dunder test. Way at the bottom of your code, in your program file, you say if dunder name is equal to dunder main, then invoke the main function. Now the upshot of this is if you are currently working on this program in your integrated development environment and you run the program, main will get called. But on the other hand, if you are working on some other program that imports this program, then that other program that imports this program will not invoke that module's main function. Okay, so why use a program? Well, a program is better able to be used in an environment involving multiple programmers working on, different parts of a big program at the same time. So I recommend that you get in the habit of using this dunder name gets, or dunder name is equal to dunder main test to make yourself a better citizen in a project involving multiple people and multiple files. Okie doke, that is that. Please, if you have any questions about anything, shoot me an email. I can respond to your email, or if you would like, I can also set up individual Zoom sessions with you as well. All right, have a good rest of the week. Take care.